Hi friends, welcome to a new video of I Square. In this video we are going to solve exercise 2.2 and the second question of exercise 2.2, and we have chosen two subparts of second problem. The next will be solved in the next videos. So in this video we are going to solve the first and the second subparts of question number 2 of exercise 2.2. And the question is that find a quadratic polynomial such that the sum of the zeros is 1/4 and the product of the zeros is -1. So we have to find, the first question is, so we have to find a quadratic polynomial such that the sum of the zeros is equal to 1/4 and the product of zeros is equal to -1. We know that any quadratic polynomial is of the form ax square plus bx plus c, and if alpha and beta are the zeros of the quadratic polynomial, then we know that alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. We have learned it in the previous classes. Now we are going to find quadratic polynomial such that alpha plus beta is equal to 1/4 and product of 0 alpha beta is equal to -1. So this is our first question. Now we know that alpha plus beta is nothing but c by a and alpha beta is nothing but, alpha plus beta is nothing but minus b by a and alpha beta is nothing but c by a. So given that alpha plus beta is equal to 1/4 and alpha beta is equal to -1, also we know that we applied our knowledge here. We know that for any quadratic polynomial of the form ax square plus bx plus c, alpha plus beta is minus b by a. So from here we have minus b by a is equal to 1/4. Also from here we have -1 is equal to c by a. Now we have to find a quadratic polynomial. See, from here we can substitute, we can choose arbitrary values. So here from we can choose a is equal to 4. See, from this fraction we can choose a is equal to 4 and b is equal to -1. So minus b by a is equal to 1/4, right? A is equal to 4, then b is equal to -1. Just substitute. When a is equal to 4, minus b is equal to, a goes up, so we have 4/4. So minus b is equal to 1, so b is equal to -1. So when a is equal to 4, b is equal to -1. Similarly, when a is equal to 4, c by a is equal to -1. We know that c is equal to -1 into 4, -4. So we have c as -4. So c equal to -4. Clear? So we have a is equal to 4, b is equal to -1 and c is equal to -4. Our quadratic polynomial has the form ax square plus bx plus c, right? So when we substitute the values of a, b and c in the form of quadratic polynomial ax square plus bx plus c, we get a quadratic polynomial. Just check. When a is equal to 4, we have 4x square. When b is equal to -1, minus 1 into x plus c, so it is equal to -4. So 4x square minus 1x minus 4 will be one quadratic polynomial whose sum of zeros is equal to 1/4 and product of zeros is equal to -1. Is it clear? Similarly, we can generate lots and lots of quadratic polynomials like this. If a is substituted as 8, then we have minus b is equal to 8/4, 2. So b is equal to -2. When c is equal to -8, so we get a, when a is equal to 4 or 2, 4, we get different values for b, minus b and c, or for when a equal to 4 we can find corresponding values for b and c. Similarly, by resubstituting a various values, giving a various kinds of values, we can generate various b and various c, so that we get different ax square plus bx plus c. I hope you understood this very well. Now we shall done the next problem also. In this problem, see, alpha plus beta is nothing but √2, right? And alpha beta is nothing but 1/3. We know that alpha beta is equal to c by a and alpha plus beta is equal to minus b by a. Now from this fraction we can substitute. You can substitute any values for a, doesn't matter. It will generate a corresponding value for c and minus b. So we can substitute any value. In particular, here we can substitute a is equal to 3. Then definitely c is equal to 1. Since a is equal to 3, minus b will be minus b will be 3 root 2. Therefore, b will be minus 3 root 2, right? So, we get b is equal to minus 3 root 2. So, substituting the values for a, b and c, we get 3x square minus 3 root 2x plus 1. So, this will be a quadratic polynomial with sum of the zeros equal to root 2 and product of the zeros is equal to 1 by 3. Similarly, we can generate load and loads of quadratic polynomial with the same sum and product. What we have to do? Just substitute a value for a, then find the corresponding value for c as well as for b. Then substitute the values of a, b and c in the general form to get a quadratic polynomial. So, I hope you understood this concept very well and very clear. If you have any doubt regarding these two problems, just comment it on the comment section. We will come up with a new video. Thanks for watching. Stay tuned.